Hello everyone, my name is Ricardo Brito and I'm here to present Carrot, a tool that I and my colleagues have developed in Ericsson to support the recommendation of code reviewers in a large-scale project. Well, why is it important to actually develop a tool to recommend code reviewers? Well, it might not be very easy to actually select a super reviewer, and there are multiple reasons for that. One, for example, you may need more knowledge about the product and people working with that product, which means maybe you are new to that product, you're a newcomer, or maybe everyone just knows the same subset of people that always review the code changes, which means that those people will be always overloaded. Of course, there are consequences for that. First one is longer review time. That's not nice, right? And of course, maybe there is a chance that people not supposed to review your code change will do that because you didn't know anyone else to review your code. And maybe this may lead to bad code being actually merged in a master branch. Should avoid that, right? Well, okay, now I think we agree. This is very important. But what about other studies that have addressed this problem? There are actually many studies out there. That's true. So why should you pay attention to my presentation? Well, there are actually good reasons. First, our study actually deployed Carrot, the tool we developed, in a live project. Then we evaluated the tool. And we evaluated the tool using data from users of the tool and people that were recommended by Carrot, which is also quite new as compared to existing literature. Then we also use a new approach in this domain. Context-aware collaborative filtering, which is a machine learning approach, has been used in other domains, but not to recommend code reviewers. Considering the good performance of this approach in other domains, it's reasonable to think that it will have a good performance to recommend code reviews as well. Finally, we made an attempt to actually tackle the problem of having just a subset of people with most of the review requests. And although I don't think we have done that perfectly, we at least made an attempt, and this is not the case with existing literature as well. Okay, so given that now I hope you are very interested in our presentation, I should state the research questions that actually guide our research, right? So first one is about the factors that we should account for when developing Carrot. Then, how good is the performance of Carrot to recommend code reviewers, mainly in relation to its accuracy. And finally, what is the feasibility of Carrot in a live project? Well, all the answers to that questions actually, are in this slide, we can say. Carrot answers those questions. Well, but what is Carrot? So Carrot is composed by 5 microservices, and Carrot was developed in Python and is able to collect data from Garrett repositories. And this data is used by a module of Carrot to train a machine learning model that is actually stored as a pickle file, which is a format widely used by the community. Then this pickle file is actually loaded by a module called recommend that does that in response to a request that may come from the Carrot frontend or via a REST API call. So the model that is trained actually once per day, since we need to do that because we have new code changes pretty much every minute. So to train this model, we use as feature previous interactions with files that one has had as a reviewer or as a contributor.
And since we have a collaborative filtering approach that is hybrid, it's context aware, we also use metadata. Basically, we use directory, repositories, and file extensions as metadata. So here you can see a snapshot of Carrot, and you can see that Carrot recommends 5 people every time. And you can see the colors, they indicate what is the workload of someone. So the orange means someone is overloaded, green means someone is okay, and yellow means this person is almost overloaded. It's also possible to provide some feedback about recommendations, and these we use to do the evaluation of the tool. So the evaluation actually had 3 different phases. First one, we evaluate use historical data, as pretty much everyone does. And for that, we use a metric called mean reciprocal rank. Then we actually ask the users, and people recommend by Carrot to share their opinion about the recommendations. Finally, we ask a few senior developers that use Carrot as well to provide their opinion about the feasibility of Carrot. Then, when it comes to the accuracy, more specifically mean reciprocal rank, Carrot uh, showed performance equivalent to other studies. So it's not perfect, but remember that this is based on the list of reviewers of a given change based on historical data. And one of the reasons that we did this different evaluation in 3 phases of our approach is because not always the list of reviewers actually, those lists, they have everyone that could review a code change, or they have adequate reviews at all. So although of course this works as a sanity check, it's not the only result we have about evaluation. There's a reason that we also ask people to share their opinion about Carrot, about the recommendations done by Carrot. And 47 users share their opinion about recommendations given by Carrot, and most of them actually agree that the recommendations are quite good. 76% agree that the first recommendation, that list of 5 that I showed before, actually is accurate. Then we asked actually those that were recommended by Carrot to say whether they feel comfortable reviewing those code changes that were actually given as input to Carrot. And then Carrot recommend those reviewers. And actually 96% of the recommended reviewers that actually answered the questionnaire said that they agree that they would be comfortable reviewing those code changes. And I think this is a very good result. Finally, we asked people about Carrot feasibility. And here we have 5 different dimensions. The first one is whether Carrot is really adequate to select adequate reviewers. And here we have 75% agreeing with that, which is a positive result as well. About Carrot's ability to recommend non-obvious reviewers. Here we have 62.5%, still more positive than negative. And we also asked about whether Carrot helps to actually helps newcomers to identify adequate reviewers. And here we have a very positive result. So 87.5% agree with that. But actually, 2 of the dimensions, we didn't have, let's say, clear winner. So, or actually have, but not supporting what we would like. So we thought that Carrot could help reducing lead time, but the overall impression right now is that that's not the case. Only 37.5% agree with this, while only 50% agree that Carrot can help balancing review load. And there are multiple reasons for that, we believe, but we could not investigate further why the respondents didn't agree with those 2 dimensions. So what is overall conclusion and future works that we envision for carrot? First, we believe that overall perception about carrot was very positive. Carrot was seen as accurate and not and useful by most of the respondents, while that was not very clear. It was not really clear whether carrot can help to reduce lead time and help balancing workload. So for that, we believe we need to investigate further and have maybe a long-term investigation to analyze those two dimensions, which we believe is what and we plan to do in the near future. Thank you very much for paying attention, staying with me until the end of this presentation, and see you around.